Welcome to the Explainer. So, you're getting ready for your GCSE Computer Science exam. Well, today we are tackling an absolutely crucial part of the syllabus, data. We're going to break down everything you need to know from section 1.2.3 about data units and file size calculations, just to make sure you're ready to absolutely ace those questions.
So here's the game plan. First, we're going to get right to the bottom of why computers are all about zeros and ones. Then, we'll climb what I like to call the data ladder, all the way from a teeny tiny bit to a massive petabyte. After that, and this is the important part, we'll master the formulas you'll need to calculate file sizes, and we'll wrap it all up with a handy checklist to really power up your revision.
Right. Let's dive in with our first section, the binary foundation. Honestly, think of this as the bedrock of how computers work. Everything else we're going to talk about today is built right on top of this.
So you might be thinking, why on earth do I need to know this? Well, have you ever actually stopped to wonder how a device that can do so much, from playing incredible games to connecting you with friends across the world, how it all runs on something as simple as zeros and ones? It all comes down to the physical hardware inside. Just imagine your computer's brain, its processor, is filled with billions and billions of microscopic light switches. Each one can either be on or off, and that's it. On we call a 1, and off we call a 0. It really is that simple. And believe it or not, that's what makes it so powerful. And each and every one of those on or off states, that's what we call a bit. It's short for binary digit. It is the absolute smallest piece of information a computer can understand. It's like the single Lego brick from which every photo, every song, and every document you've ever used is built.
Okay, so let's move on. How do we get from a single bit, just one tiny little Lego brick, to the enormous files we download and stream every single day? Let's take a look. So, one bit by itself can't really do a whole lot, right? So we group them together. If you group 4 bits, that's called a nibble. A much more common grouping, 8 bits, makes a byte. And from the byte, we start climbing the data ladder. Now, these are the units you are absolutely going to want to remember for your exam.
And here's a fantastic tip for your GCSEs. Just look at the pattern. Each step up is 1,000 times bigger than the one before it. A kilobyte is 1,000 bytes. A megabyte is 1,000 kilobytes. You see? This simple rule of thumb makes remembering the scale of these things so much easier.
Okay, here is a really key piece of info, and this comes straight from the exam board. Now, while we're using 1,000 for simplicity today, you might have learned that a kilobyte is actually 1,024 bytes. Well, the good news is the examiners will accept either one, so you're covered. Just make sure you stick to one or the other in your calculations, and you'll be fine.
And just to give you a sense of the absolutely mind-boggling scale we're talking about here, a single petabyte is 1 quadrillion bytes. That is a 1 with 15 zeros after it. It's incredible. We went from a single tiny switch to this enormous number in just a few quick jumps up that data ladder.
All right, now for the really practical part. This is what you've been waiting for. Your exam is absolutely going to expect you to use this knowledge to calculate file sizes, so let's get right into it.
You are definitely going to be tested on your ability to figure out the size of text, image, and sound files. So let's go through the 3 essential formulas that you absolutely need to commit to memory. Let's start with the easiest one of the bunch, text files. To find the size, you simply multiply the number of bits used for each character by the total number of characters in the file. For example, standard ASCII text uses 8 bits for every single letter, number, or symbol.
So let's walk through it. Imagine a text file with 100 characters, and it's using that 8-bit ASCII standard. The math is just 8 times 100, which is 800 bits. And since we know there are 8 bits in a byte, that comes out to a nice, round 100-byte file. Simple as that.
Okay, next up, images. To calculate the size of an uncompressed image, you've got to multiply 3 things together. The color depth, which is just the number of bits used for each pixel's color, the image's width in pixels, and its height in pixels. Let's try an example together. Say we've got an image that's 500 pixels wide and 200 pixels high, with the 24-bit color depth. The calculation is 24 times 500 times 200, which comes out to 2.4 million bits. And finally, let's talk about sound. For an audio file, you're going to multiply the sample rate in hertz by the duration of the audio in seconds, and then by the bit depth. So, picture a 10-second sound clip at standard CD quality. That means it has a sample rate of 44,100 hertz and a 16-bit depth. So we multiply 44,100 by 10 seconds, and then by 16 bits, which gives us a file size of just over 7 million bits. So look, the most important point here is that you have to learn these three formulas. I can't stress this enough. Understanding them, and more importantly, being able to apply them is absolutely essential for doing well on this part of your exam.
All right, we've covered a lot. Let's bring it all together with a quick, clean checklist that's going to help you really focus your revision. So, let's recap everything. First, get comfortable with those data units, from bit all the way up to petabyte. Second, remember that simple conversion rule. Each unit is 1,000 times larger than the one before it. And third, and this is the big one, make sure you know those three formulas for calculating the file sizes of text, images, and sound inside and out.
And I want to leave you with something to think about. A single petabyte can store 500 billion pages of text. With the amount of data in the world growing so incredibly fast, what do you think the next unit of data after the petabyte will be called? That's our quick guide to data units and file sizes. Best of luck with your revision.